Welcome back. This is video 2 for lesson 5.5. On to our theorems that will help us factor. The first one is the remainder theorem. If a polynomial, f of x, is divided by x minus k, so we're talking about a situation where we can use synthetic division because we're dividing by a linear term, then the remainder is r equals f of k. And we know this. We know this from synthetic substitution. When you substitute in k, you look at that last part, that remainder, and that gives you f of k. So this is just really confirming what we did when we did the same process, but referred to it as synthetic substitution. Well, related to that is the factor theorem. A polynomial f of x has a factor of x minus k if and only if f of k equals 0. So if we end up with a remainder of 0, that means we started off with a factor, and that's a great thing to have. It also means that k is a 0 of our polynomial. So if you divide a polynomial by x minus k and the remainder is 0, then x minus k is a factor of the polynomial. So let's look at an example. We're going to factor f of x equals 3x cubed minus 4x squared minus 28x minus 16 completely, given that x plus 2 is a factor. Okay, so that's what we're going to do. So another way to factor polynomials of fairly large degree 3, 4, man, we could even do 5. But let's get started here with just one that's to the third power, a third degree polynomial. Because x plus 2 is a factor of f of x, you know that f of negative 2, because remember it's x minus k, so this is x minus negative 2, so k is negative 2, so f of negative 2 is 0. Use synthetic division to find the other factors. Well, how's that going to help? Well, what we're going to do is we're going to use synthetic division to help us factor out the x plus 2, and then we will have the quadratic quotient. How do we know that it's going to be quadratic? Because remember, we're starting off with x cubed, so when we divide out one factor, that's a linear factor that's going to take us down to x squared. All right, so here's our negative 2, and we write our coefficients. So we've got 3, negative 4, negative 28, negative 16. We didn't skip any degrees, so we don't need to fill in with any zeros, so we're good to go. So we bring down the 3. 3 times negative 2 is negative 6. You add down the column. So negative 4 plus negative 6 is negative 10 times negative 2 is 20. Negative 28 plus 20 is negative 8 times negative 2 is 16. Negative 16 plus 16 is 0. Well, we expected that because we were told ahead of time that x plus 2 is a factor, so that means the remainder should be 0. All right, we're going to use the result to write f of x as a product of two factors and then factor completely. So we're going to write the original polynomial, f of x equals 3x cubed minus 4x squared minus 28x minus 16. And then we're going to write it as a product of two factors. It's going to equal that x plus 2, and then our quotient times 3x squared minus 10x minus 8. All right, we're going to factor that trinomial. All right, so you're probably going to have to do the full-blown AC method unless you're just really good at guess and check. Take a moment to do that, and then come back. So just pause me and then come back. Okay, so if you did this, you're going to find that you end up with 3x plus 2 times x minus 4. Let's just double check that that really is the factored form of 3x squared minus 10x minus 8. 3x times x is 3x squared. And when we multiply the outside, we get 3x times negative 4 is negative 12x. Inside is 2x. Negative 12x plus 2x gives us negative 10x. And then 2 times negative 4 gives us negative 8. All right, so here we have the completely factored form. Okay, so that's the answer. We know we're done because we've got 3 little binomial factors. We can't possibly go any further. All right, let's look at standardized test practice. 1, 0 of f of x equals x cubed minus 2x squared minus 23x is x equals 3. What is another 0 of f? Okay, zeros and factors are linked. Since we know x equals 3 is a 0, we know x minus 3 is a factor. Okay, so we're going to be able to use a very similar process to what we did. They're just telling us what k is here, and they're wanting us to take factors all the way down to zeros using the same process we just did. Okay, because f of 3 equals 0, that's what it means to be a 0, x minus 3 is a factor of f of x, so we're going to use synthetic division, just like I said we would. All right, we have 3. Oh, the little arrow's not written there, but we know what to do there. So we've got, first, let's talk about getting this top row. Remember, that's just the coefficients. So you have 1, -2, -23, and 60. So we bring the 1 down. We really should have a little arrow written there. We bring the 1 down, and we do 1 times 3 is 3. -2 plus 3 is 1, times 3 is 3. -23 plus 3 is -20. Times 3 is -60. 60 minus 60 is 0. All right, so we're going to use the result to write f of x as a product of two factors and then factor completely. So here's our original. We've factored out the x minus 3, and our quotient was x squared plus x minus 20. So now we need to factor the x squared plus x minus 20. This one will be a little easier to factor. We want numbers that multiply to be -20 and add to be 1, so +5, -4. All right, so here's our three factors. We can find zeros by just setting each one of these equal to 0 and solving. So x minus 3 equals 0 gives us x equals 3. X plus 5 equals 0 gives us -5. X minus 4 equals 0 gives us x equals +4. So all three of these are zeros. Now, the way the question was asked was, okay, 3 is a 0. Which in the following is also a 0 of f of x? So we should find either -5 or 4 as one of our answers. And if we go back and look, let's see. Choice A was -5. +4 doesn't appear anywhere, so A is our answer. All right. Last example, yay! We're going to use a polynomial model. I like for y'all to see that why we're studying this, okay? First of all, it's just good to have a complete body of mathematical knowledge at this level. But the other reason is it's just useful, okay? People use mathematical models all the time in the real world, and a lot of times a polynomial model is the best model you can use. The profit P in millions of dollars for a shoe manufacturer can be modeled by P equals -21x cubed plus 46x, where x is the number of shoes produced in millions. The company now produces 1 million shoes and makes a profit of $25 million, but would like to cut back production. What lesser number of shoes could the company produce and still make the same profit? All right, we're going to substitute 25 for P in P because remember these things are in millions. So we're going to get 25 equals -21x cubed plus 46. We're going to write it in standard form. So we've got 0 equals -21x cubed plus 46x minus 25. I'm going to divide everything by -1 just to make my life a little easier. And so when I divide 0 by -1, it's just 0. And then it equals 21x cubed minus 46x plus 25. And remember, that's perfectly fine as long as you're dealing with an equation because you can do it to both sides. So I'll look at it and go, am I skipping any degrees of x? And I sure am. I am skipping from x cubed to just x to the first, plain x. So I need to fill in with 0x squared. We know that x equals 1 is the solution of the equation. That implies that x minus 1 is a factor of 21x cubed minus 46x plus 25. So we're going to use synthetic division to find the other factors, just like we've been doing. So we put in the 1, and then we use our coefficients, 21, 0, -46, and 25. We bring down the 21. 1 times 21 is 21. 0 plus 21 is 21. 21 times 1 is 21. -46 plus 21 is -25. Times 1 is -25. 25 minus 25 is 0. So x minus 1 times 21x squared plus 21x minus 25 equals 0. Well, you can try to factor that. It's just not going to work. So we can always use quadratic formula. You just set the whole 21x squared plus 21x minus 25 equal to 0, and you solve. Well, when you do that, you get a positive solution and you get a negative solution. You can't have a negative solution. They can't destroy a bunch of tennis shoes and make profit, okay? You just can't do that. So x equals 0.7 is the other positive solution. And so the company can still make the same profit, producing about 0.7 million, which is 700,000 shoes. So they've got an option. They could do that. Okay, guys, that's it for your examples. You've got a couple of problems to try on your own, so go ahead and do that. Make sure you do that. That's an important part of being prepared for class. If you can't even get started, then that means you need to come in and see me before class starts, just so that you can be where you need to be able to do your rounds. Okay, guys, have a great day. I will see you soon in class.